Okay, hello, hello everyone. Welcome to the coding session of Trading Signals. In this episode, I'm going to continue my work where I left it in episode 2. So essentially, I am working on defining all the possible trading signals that we are going to be able to emit from a trading bot. And I believe there is one type of signal that is missing. I thought that I finished all of them, but it is not the case. So let's check this out. um, we already have the trigger stage covered, the open, the manage, and the close stage with everything inside supporting signals. Okay. What I notice is that at the open stage and the close stage, there is an event to close the stage. That you can add it if you put here add missing items. So there you can see this guy. Okay, so I don't think this is here, add missing items, or probably it is. Manage stop loss, no. User defined code, no, we don't need this one. But yeah, we have it also at the close stage. Okay, so we are going to enable this event also to be able to produce signals, outgoing and incoming signals. Okay, so because this is a continuation of the previous work, I will be going to here. This is the Visual Studio Code I was working before. So let me check this out. We have an event at the open stage. Okay, so at the event we need to add something very similar to this, the outgoing and incoming signal menu items. Okay, so that's what we're going to do first. So we need to locate the CloseStageEvent. CloseStageEvent. Let me find that. Okay, again, this is a node that is at the Foundations project still, because the migration to the algorithmic trading project is not finished. So I look for it here, CloseStageEvent. Okay. So I will need some of the ones that I already did. For example, the face node. Where is the face node? Just these two guys here. From the face node, I will get the two menu items that we need, outgoing and incoming, and I will add it to the event node. Also, we do the same stuff with the children definition, outgoing and incoming. Okay, I will put it here. Between portfolio and announcement, that's what I'm doing. Okay, so this means that The, the open stage and close stage will have a menu item for each of these two incoming and outgoing signals. Okay, another thing that we need to do is in the incoming and outgoing signals, we will need to add this as a possible parent. So outgoing signals, let's get it here, and incoming signals, let's get it here, and we are going to add the open stage. Let's see, the open stage and the close stage. Okay, these are two possible parents, so we are going to add it to the attaching rules of compatible types. Okay, so open stage and close stage. And exactly the same thing, we are going to do it at the outgoing. Open stage and close stage, good. Okay, so this will allow us to create, no, no, it's not the place to do this. No, because these are not events of the stage. This is the event. So the one who needs to have, okay, let me see because I'm confused. Close stage event. What did I do? Manage stage. Okay, I will start removing stuff that I don't need. Face, signal, goodbye. Next, move to signal, goodbye. So, okay, this I did it well. I put the menu items at the close stage event, okay? Yeah. The problem is that this I did it wrong because what I need to do is to put the close stage event as a parent of the outgoing and incoming, not the stages themselves. Okay, so I'm going to correct this here and also here. Okay, so now we are good here. We will be able to create from the closed stage event the incoming and outgoing. So the next thing we need to do is to go to the user profile and at the open stage we have all these possible signals: limit cell order, limit by orders, blah blah blah. What we need to add here is, probably I will make this tidy here. We will add one new node here to the open stage signals and to the closed stage signals that is going to be called like this: closed stage. Oh, there is a problem, because if you put closed stage signal replacing event for signal, maybe it's going to be a little bit confusing because we have a closed stage signals now. but I'm just going to follow the naming convention that I'm keeping without putting the event. So I'm going to create a new node for that. Okay, so let me find, one that I can use to copy the content. For example, the facing. Okay, so facing. Okay, so I'm going to create a new file. It's going to be called close stage signal, which represent the close stage event signal. Close stage signal. Okay. So here it goes, close stage signal. And this is not going to have any children. I think. No, because it's just an event. So I don't need this, and I don't need the children definition either. But I will need to change this. Instead of face, close stage, and in singular, because it's only one event possible. Okay, close stage signal. Okay, so this is the new node, close stage signal, and it's going to be attached to the open stage signals node, open stage signals node, and the close stage signals. Signals in plural. Now I'm seeing that I have a typo here. Close stage signal. Okay, close stage signal. Okay, so essentially this guy is going to have yet another child. We're going to put it, it's going to be a child that is not an array, but one that we need to check the property, like this one. So we're going to copy one of these. And I'm just going to put it at the end of the list right now. So like this. The property to check for is the one that comes here. The node type is exactly this one. This goes here and here. And we will add one more child at the end of the list, where the property name of the child is going to be this one. Look, this is the problem with copy pasting. It's very easy to leave something bad. Okay, you need to be careful with that. It needs to be exactly the type of the node here. Okay, So we have it at the open stage, exactly the same stuff. We need to do it at the close stage. So the names are going to be very similar, one with an S and the other without an S. I don't really like that, but that is the naming convention I'm following now. So the new child is exactly the same. Is the new node that we are creating. What else? So we have at the parent the definition of the new child. At the child, we have the property at the parent. We will need an icon for this guy. That's what we're going to get now. Not here, but here. So one more of these guys. And we have the icon. Okay. What else? There's one missing stuff. There is that when we are able to create the outgoing or incoming signal, there will be a signal reference node that needs to reference the new guy we created. So we need to find the signal reference node. Where is this guy? I don't remember the exact name, so I'm going to check it out here. Outgoing signal reference. So there are two. One outgoing and one incoming. Incoming signal reference and one outgoing signal reference. So I'm going to copy the new node type and add it to the possible nodes this can reference at the end of the list. Well, it doesn't really matter if it is at the end or where. It really doesn't matter. Doesn't matter. Outgoing also. Okay, and that should be enough to make this setup work. So I'm going to refresh this, or probably save it before refreshing. Refreshing. This is going to reload. It's going to take a while. Okay. My plans are, if we have time, yes, we have time. Once I have this last piece of the puzzle set up, I'm going to try to debug to make sure that all this stuff is working, and also to explain a little bit how it's working. And after a little bit of verifying that everything is in place, I think that we can close this episode. Yeah, that would be a nice place to stop. Okay, let's go to the code again. This already loaded. So we are here, open signals. Oh, this is getting crowded. Add close signals, close stage signal. This is the event that we just defined, right? I can put a name here. I was putting a name, but that's just not really necessary. I will just leave it like that. And at the close, we can also put a close stage thing. It's getting a little bit crowded. Okay. It looks good to me. Then we come here to the trading system where the outgoing signals are. And we're going to, okay, at the open stage, we already have the CloseStageEvent. Now it has the menu that we added. We're going to tidy this a little bit. Outgoing reference. We're going to do the same here to have everything tested later. Okay. Okay, so let's connect this guy. We're going to take it with Ctrl Shift Z close to here. And we're going to reference this guy. And because we add it to the list, the reference can be established. So you can go. Then we'll pick up the other one that is over here. Pin it. Connect it to the other one. So what we are saying with this is that when this signal is emitted, broadcasted, it's going to go through this node. Okay, so whoever wants to receive this signal, they need to establish a reference to this node for this specific signal. That is exactly what we are going to do with our second strategy, the one that is receiving signals. Okay, so what we are going to do is to map the event. We don't need this guy. Because the event is the same, we did it only once to add these menu items. So this is going to be incoming signals, incoming reference. At the close stage, add missing items. We don't need this guy. And add outgoing signals. And we have the two guys that are going to be receiving. So we will connect this to the signal definition. The first one is to be connected. Let's close this to this guy. So we go and connect it. It's connected. So it can go. And the second one, we are going to connect it to the close stage signal definition here. It is connected. So this one can also go home. Okay, so we save everything. And we are pretty much done. Now, as far as I can see, every event that can happen in these trading systems and every formula they are all wired to produce signals or to consume signals. Okay. Okay. Let's do some testing to verify that all this is going to be working. But since everything is more or less fitting in place, what I'm going to do is to create a commit here, just in case that we have to come back. Open and close stage. Close stage event signal implement. Okay. Good. So how do we test this? How do we test this? We will need 3 different Visual Studio codes open at the same time. Okay. I will have to remove all these files because otherwise they're going to be distracting. So close all. Easier. Okay. So what we will be doing at this task server is using the strategy that is sending the signals. Okay, this is task server. The other one is task server 2 that we are going to use for the incoming signal. So we won't need this, and we will need to open the algorithmic trading project, TS task server, low frequency trading, this thing that is called trading stages. Okay, trading stages is the place where we are evaluating if the trigger on event is triggered or not. Okay, it's not trading simulation, it's trading stages. So if you check this out here, when each stage runs, for example, the trigger stage, we check the trigger on, trigger off, or take position. Okay, so we have a function for each of these. The same is for the open stage, the manage stage, the close stage. Okay, and there are some other functions that help us does all this work. Okay, let's put this a little bit more tidy. Okay, so we will test first this trigger on, trigger off, and take position to see if there is any problem here. The way we are going to debug this is, because this is the process sending the signals, we should stop at this line 173. The logic here is that when we evaluate the situations and conditions, and that evaluation is true, past, this past means past equals true, then we are doing all of this stuff, and as you can see here, we do the announcement to the social bots Twitter, Slack, Telegram, whatever. But before that, we are going to broadcast the signal, okay? Because this is an event. We have this function broadcast event, broadcast signal, that we pass this stuff. And we are going to make sure everything is working. It was working before, so it should be working now. Okay. So at the other end, task server 2, we will also open the same file. That means algorithmic trading stages. Okay. And at the trigger on, instead of portfolio, we don't need this. Here is where we check for the signals. As you can see, we first check for the signals and then we evaluate the conditions. And the reason for that is because the signal themselves can be part of the conditions, which is really powerful. Because it's not only about if the signal exists or not. Remember the condition, the signal, if they are triggered by a formula node, they will come with a formula value. And they might have also context information, as much information as you wish, or the signal provider wishes to expose. So any of that information will be available at the evaluation of the conditions. That means that the evaluation can be very rich. Okay, so we are going to stop this here. The third component that we are going to need is a network node to be running. By the way, I had it already running from before, but let's stop it. This is a network node. So far, the only thing you need to do is to stand on top of this file and hit F5. For this, you need to have at your profile configure a network node, at least one. I have in my profile configured, in fact, 2 network nodes because I was testing this stuff, but actually you only need one. Okay, so with one network node is enough. Remember when you configure this to change the default web port and WebSocket port, because otherwise it might happen that other users have the same web port or WebSocket port, and even though you're not running the same machine that other people, but it might create confusion. And my advice is that you pick your own. So my network now is running, even though it has these warning messages, or there are results of some tests I've been doing before. But I can see it's running because I can see this stuff. Okay. The network nodes have a WebSocket interface and HTTP interface. Briefly, the WebSocket interface is where all nodes get connected to each other, and also all applications get connected to nodes, except for the case where an application wants just to send a signal. Okay, to send a signal, you don't need to be all the time connected via WebSocket. So we are using an HTTP interface where the signal is just an HTTP post. Okay. So once this is running, we'll go back to the task server number 1, or without number, and we will run this stuff. Just to clarify, the network now is 100% independent of the platform and the user interface and the task server. It's a 100% different application and is unrelated to this, and the only way they have to communicate is via this WebSocket interface of the network node. Okay, so the platform is going to play the role of a network client and is going to connect to that network node. Okay, so that's why I can run the node and it's independent of all this. So the next step is to run the trading, one of the trading bot, the ones where signals are going to be broadcasted from. F5 to run it, and because I wanted to run it in debug mode, right now when you press F5, is the process is running, but it's disconnected to the rest of the platform. Okay, so it's essentially waiting for an event, a debug event, to happen. And the way that you have to produce that debug event is to start the task. This is the outgoing signals. Okay, sending signal. Is the way to start to link the platform with the Visual Studio Code that is running is to send the debug event using this option. Okay, once you do it, this task, oops, something's wrong. Okay, so once you do it, you're essentially establishing the connection between the platform and that instance of a task of the task server, the one that is running inside here, Visual Studio Code. Also, because the user interface sends the information of the task, as you can see here, the task itself has a new child, that is task server app 1. What does this mean? Task server app 1. This is a reference to an application that I have declared here at my profile at this area of user applications. Okay, every user have to explicitly declare the applications they are using in order to make all this reference possible and everything fits at their place, right? So what I did is here at the area of server apps, okay, server apps, I have a task server app number 1 and task server app number 2. Okay, in the future we will have also a social trading server app. This doesn't exist today. Okay, but what this means is that a task like this one, this is the way I have, or we have to sorry, here, this is the way we have to connect a task that we are defining here on any workspace with one of the tasks that we define at our profile, that means are the possible clients applications to the network. Okay, all these applications here, we are explicitly defining them because we need them to run with a certain identity. Okay, remember that to send messages through the network, every message needs to be signed, cryptographically signed. So that means that each application accessing the network needs to have a signing account. Okay, I will explain probably this in another video on all detail, but what this means is that the user profile that also have a sign-in account, or the user profile is expected to hold the SuperAlgos tokens, right? So we don't want to use the private key of the user profile at your phone or at your PC or at your server, okay? Because that would be a security risk. So it is much better if each application have their own private key that they can use to sign their own messages, okay? So that's why each application must be declared explicitly and must have their own sign-in account, like this one, okay? So everything is perfectly identified by anybody, because all these profiles are plugins and are part of the code base. That means that any node in any place they are running, they have access to all these plugins and all these definitions. So they know that if an application is trying to connect to themselves, they know which application it is, because this application need to sign their messages, and they can validate that the signature is okay and that they are who they are saying they are, okay? Because the signature can be validated. Okay, so essentially here this task is running with that identity in particular. But that is like a certain layer of communication, where at the application layer, let's say, where the application task server is communicating with the network node, okay, at the application level, okay. On top of that layer, the application layer, you have the social layer, where you have the bot that is going to be emitting signals, okay, or consuming signals, okay. They also have an identity well defined at the user profiles, okay. And this is the way you connect the bot that is running in this task with a social bot. This is a trading bot, okay, low frequency trading bot, and this is a social bot. The social bots are the ones that users can see when they use social trading applications. They don't see the trading bots, okay. So via one social trading bot, probably many trading bots are sending signal through, okay, or maybe only one. Nobody knows. What social trading users see are social trading bots, and they don't know what is behind them. Behind them, there are trading bots, okay, and the connection is established here, where if the bot has this reference to a declared and well-known social trading bot, okay, and once this is set up in this way, then there is another layer on top of this. There is the signals themselves. Each social trading bot has a structure of declared, well-defined signals that it can produce. You can see it here. You see, here I have two social trading bots, and available signals is the node that defines which are the signals that this bot in particular can have, okay. So each bot may have one or all of these signals, or any of these signals. Well, if it is a bot that is consuming signals, it may have none. But these are the available signals, are the signals that this bot is able to produce, okay. So this bot might broadcast any of the signals that we have been defining during the last episodes, okay. And at this layer is where we were working before, where at the trading system we were connecting the events of the trading system to this signals definition for the outgoing signals. case and also for the incoming signal case. Okay, and that is how everything is tied together. Okay, so we have this bot running. You have this bot running, and we need, in fact, we don't have the bot running. To be more precise, we have the task running. Okay, the bot is running when we run the session. When we run the task, it's just the process is there and is waiting for the session to be run. That means that the bot is not actually running. But we need the procedure to have more than one, to debug at the same time more than one task server. It has a very specific order, is that you need to run the task at Visual Studio Code first, then hit debug at the user interface for the first task. Then after that, you can go and run the second task, okay? And the reason you have to do it in sequence is because they are going to be listening to the same event. So we actually need this to be at the same. One second. To be at the same. We need to run it one first and then the second one. Okay. So now that the second one is running, I'm going to come here and I'm going to run the second task also with debug, sending the debug event, and we will see at the task server that this is running. Okay, because the both tasks have this node, then the task is going to connect itself to the network node. Okay, if today's data mining task of any other trading bot that you might have that does not have this node, you're not going to see these logs because they are not going to even try to connect because they cannot get any identity to connect through. Okay, so yeah, but when you do have this node, you must see this this kind of logs here that represent that a network node was found and we are connected. Okay, so now both tasks are running. What we are going to do, how do we do this? Well, yeah, we are going to do the test in this way. First, we are going to run the trading bot emitting the signal. From here, and it should stop at our breakpoint. Okay, so well, I didn't expect this to stop somewhere here. Something is not good. Okay, probably it is. Yes, it's running. I know exactly what I did. Probably I pressed some key that is not. Okay, and there we have it. It stopped here at the place where we are going to broadcast the signal. Okay, so this is exactly what we are going to do. We are going to follow this. We'll place a breakpoint here just in case we need it. So we enter here. I'm going to show once how this is working. So here here we are inside the broadcast signal function of this module, outgoing trading signals. And so for each signal reference, essentially where we are is here at this trading system. At the trigger on event, it detected that it's testing to see if it has to broadcast this stuff. So for each outgoing signal reference, in this case there is one, and I use only one for all these tests. But you may have more than one reference and send signals to many different social trading bots at the same time if that is what you want. But in our case, there is only one. So here we are seeing if the reference has a reference parent, blah, blah, blah. And we will get which is the social trading bot, okay, social trading bot 1, the bot code name, which is the application identity that we are using. Okay, in this case is task server app 1, what I already explained, and some other information. Okay, and then we are evaluating the signal context formula. I explained this briefly before. Essentially, what you can do is to create a formula here, add signal context formula, where you can freely create a context object where that if you do, all the information you put in that object is going to be part of the signal message, okay? So essentially what we are doing is evaluating that so that we have the context object. In this case, I don't have it in this example. But maybe, well, this is the signal message structure that is going to be documented after I finish all this. But this is the information that is going, a unique ID, a timestamp, which is the source object producing the signal, the type of the object, if the object has a formula, the formula value, and the context information that comes as a result of evaluating the context formula. Okay, there's some information about the broadcaster, in this case the user app, the social trading bot, and things that I can imagine are going to be useful later on. So this signal message is going to be signed twice, two signatures, one by the user app and the other by the social trading bot. Okay, because at different layers we will need to verify that this is correct. Okay, once the signatures are calculated and are there, then this goes to the last step here, where the message is going to be sent via HTTP, an HTTP client of the network node. Okay, and pretty much that is what is going to happen. Before sending this there, what I'm going to do is I'm going to just explain this process like completely. Well, I'm going to go a little bit deeper inside here. And I'm going to enter here. Okay, this is exactly the point where this is sent via HTTP. Okay, let's put it there. Okay, so to make the whole process very clear, I'm going to put some extra breakpoints. One at the second task server, I will use outgoing trading signals. Where is this? Okay. So at the trading signals project, which is not this one, but here, incoming trading signals. Okay. Well, probably there is too much detail here. I'm going to jump this because it's going to be too much detail and too deep. So what is going to happen here is that the signal is going to be sent to the peer-to-peer node over this HTTP interface. The peer-to-peer node is going to run some validations, and then it's going to go through all the connected WebSocket clients and send the signal to each of them. So far, the only one connected is our second task server. So the signal is going to be taken by the task server, and it's going to be stored in memory somewhere. And once the bot runs, remember that one thing is the task and the other is the bot. So the task is going to store the signal until the bots run, or probably the bot is already running. But when the bot is running, it's going to grab the signal and it's going to have it available. Okay. So essentially, if I run this, everything I said should happen. Okay. So stop at the next line, and if we let this run, it's going to send all the signals that happens during this execution of the trading system. So I'm just going to let it run, and it's going to send, I don't know how many times, this stuff over and over again. Okay. So this is the first task. Okay. So the first task was already run and sent all the signals. And we are going to run the second task that have a breakpoint where it is going to read the signal. So we run it here. I don't know what I did that now this is stopping there, but let it run. So first it loads all the stuff, and it should stop at our breakpoint. There it is, where it's going to check for signals. Okay, so it's going, in this case, it's going to check for signals of trigger stage, trigger on. Okay, so let's follow this a little bit deeper so that you can see how it does it. Check for signals come here. So it's going to check that the node trigger on has incoming signal node and references. So for each reference, it's going to do this. And this is something that is a to-do for me, because now I'm returning the first signal only, but this might have many different signals. Okay, so this is the next thing I need to fix, in fact, and it's right here. Okay, so what this does is to come to this peer-to-peer network interface get signal function, giving the ID of the signal definition ID. This ID is essentially the ID of these guys. Okay, these are the signal definitions. So when you are following a particular signal at the signal level, not at the social trading bot level, but at the signal level, then you will be following one of these guys, trigger on in particular. So the idea of this node is the one that is being used here to fetch specifically the signal related to that node. Okay, so it's only for that specific signal, even though the other process sent a ton of signals. Okay, so this is going to come here. It's going to come here, and as you can see, there is a map that is called signals by signal definition ID. Okay, so there is a map for each type of signal where by ID we are going to get what is stored at that map. In this map, okay, there is an array of signals specifically. In this case, only one object there because there was only one trigger on event happening, right? But it might happen that it might accumulate many different signals for whatever reason. So it is an array. So far in this current implementation, that is the first iteration, what we are going to do is grab the first item of the array, okay, and take it out of the array with this splice and return this object. This is the signal object that if you check it closer, okay, you will see that it has exactly the same structure that we said it should have when we were watching this. Okay, so there is this, the signal object has a unique ID, timestamp, source, broadcaster, all this information including the formula value if it had. Okay, so broadcaster, and well, source, trading system, node. The type of the node that produced the signal was a trigger on event. There was no formula value in this case, so this formula is like empty, and there was no context either. So there was no context formula. That means that there is no context object, but it would be there. So once you have this signal here, you start returning, and it returns here, and it returns here. So we have the signal here at the place where the trigger on conditions are going to be evaluated. So we send this to the eval condition, okay? We send the signal. So here we go again. The eval condition is going to do an eval node, but eventually it's going to end up in a function called eval condition. So we just jump there, eval node, eval condition. So we come here. Okay, so we have our signal here. Yeah, perfect. And as we have our signal, we are about to eval the code. Not just yet, but here, okay? So the code says if signals is not undefined, so if there is a signal, then it returns true, otherwise it's false. So because we have a signal and we put it in here, this very simple code doesn't care about anything coming inside the signal object in this case. But remember, this is a condition to see if you're going to trigger on the strategy or not, right? So in many cases, it might work just to say, if there is a signal, then we trigger. If there is not, then we don't, okay? So we are going to evaluate this, and because there is a signal, this should be true. Value true, okay? So essentially, what is going on is that our second strategy is triggering itself on because the first strategy did a trigger on, right? It's exactly what is going on. So if we let it run, you will see that once we run all through this stage, this is going to be a pass because the condition was true. The condition already calculated was true. So essentially, we're going to be triggering the second strategy. And that is exactly what we were expecting to happen. If we follow this into the formula, we probably will be able to see the context object. Let's do that. Okay. So this is fine, but we want to see what happens with the formulas. That is the second use case. We have signals triggered by events and by formulas. Okay, so we cover so far the debugging of an event-based signal. The next thing to do is to see the formula-based event. So for that, what I'm going to do is here, we're going to stop in eval formula. Let me check this to see if I remember what was done. Okay, in the case of any formula, the signals are not. Let me remove this breakpoint so that it can freely go. In case of formulas, the place where we retrieve the signals are just before the formulas are evaluated, okay? So if you see here, eval formula, okay? We make the call of incoming trading signals here, and then we evaluate, okay? So we will let it run so that it stop here, and it should stop at the first formula of the trading system, that is, I will tell you exactly which one. We are here at the incoming trading system. The trigger stage doesn't have any formula, but the first formula to evaluate is this one, the initial target formula, okay? This formula, okay? Then it will evaluate this one and so on. So this formula have this incoming signal, and the one who is triggering that is on the other trading system, initial targets, is this guy, okay? But in this case, I added a context formula to the outgoing signal. So when this formula was calculated, this formula, what does it have? It have the candle close value, okay, taken from the trading engine. That's the formula, and it's going to go automatically inside the signal as object. But here I added a signal context formula where I have the creation of the context object, and I return the context object like this. And in this case, I'm retrieving 3 different values from the trading engine, like random stuff that I pick: profit loss, hit fail, and ROI. Okay? So this signal was already broadcasted, and it should be at the task of the receiving side. Okay? So what we are going to see and check if this worked well, we're going to run this up to here. So we need to let this go, eval condition. Okay, and we are here. So if you see, check the parent node here, we are talking about the target rate node. That is exactly the one that we are expecting here. Target rate node. We are here. Just stop here. So it's going to go and do the same stuff. Check if there is a signal for this parent node. So we already did that. So we are going to just go to the next step and we get the signal. Okay. So in this case, we're going to print this here. Or maybe even better if we can see it here directly. So the signal object we receive in this case have also a source that is at the trading system and at a node of type target rate with a formula value of the candle close at that place, exactly this, and the context information created by the context formula with this information. We have 0, 0, and well, is whatever it was there at the trading engine at this place. Okay, so that this means that our formula can use any of this stuff, and in this example the code this is going to run is going to use, if signal is not undefined, it's going to use the signal formula value. Okay, it ignores the context, it doesn't care. Okay, so our formula then is going to have exactly the same value that the formula of the trading bot that emitted the formula signal. Okay, what that means is that probably I can run a bot without any data at all, without data mining, because I'm just following the signals, and the signals are providing me with all the information that the bot that is executing is calculating itself. Okay. So this is it. So to recap, let's make a little bit of recap. What we have done now is to finish the definition that was missing of the trading of the event to close stage. And then we explain a little bit how the signals and identity works, the application identity works, and how the tasks are linked to those identities. And also we debug the circuit that happens when a trading bot emits a signal and when a trading bot receives a signal. And we learn that there is two types of signals, essentially: event-based signals and formula-based signals. In the case of formula-based signals, the formula value is added to the signal and is available and can be used. We use it here. And in both cases, the outgoing signal reference node can have a child with a context formula where you can create an object and put there whatever information you want. They take it from wherever you want that you have accessible to you at the trading bot emitting the signal. One obvious place is the trading engine itself, but you might get information from the session parameters or even indicators. You can put indicator data if that is what you want. So whatever you put there, and in whatever structure you put there, is going to be inside the signal object, and it's going to be available to the bots consuming the signals at evaluation time of their own formulas, so that they can use any of this information to make the decision they want for the formula they are calculating. Okay. Also, it's going to be available at the conditions in the case of events formulas, event signals. So any information, even context information, is going to be available for evaluating the condition. It doesn't need to be as simple as a signal exists, but also you might want to evaluate whatever of the information that is coming attached to the signal in the form of the context object. So I think it's really very powerful. It's really very, very flexible. Okay. It fits very well in what we have as of today. So we are adding more power to what we have today. We are not losing any features that we already have. It's fitting together with what we already have in terms of spreading information through social bots, Slack, Twitter. That is a different circuit and is unaffected by this. And both the bot emitting signals and the one receiving the signals can still rebroadcast this via Twitter or whatever they want. And it's also going to be fitting very well with the works that are being done at the portfolio manager. So this doesn't interfere with the portfolio manager itself. The logic of the portfolio manager is independent to this. So everything can work together peacefully and hopefully seamlessly and very well. So I think that this is all for now. Thank you for watching. I hope you learn a lot. This topic of trading signal has been covered by these first 3 videos in quite detail. I'm going to continue producing more videos of this topic as I advance. And thank you for watching.